Welcome to the AP Statistics Infomercial. I'm your host, Mr. Klein, and what I'm going to do over the next 3 to 4 minutes is try to convince you that next year you should sign up for AP Statistics. Here's a few reasons why. Those who know statistics are a step ahead in school. Here's what I mean by that. If you know statistics, you're going to have an advantage in the following classes. AP Bio and APES. AP Bio, they talk about the chi-square test for homogeneity. APES, they might do chi-square too. They definitely work with standard deviation. AP Psych, AP Gov, AP Econ, these are all social science classes, and they're all classes where knowing statistics puts you ahead of everyone else. And then obviously the math class is pre-calc and calc. So one of the cool things about statistics is that we're working in everyone else's backyard. You get to mess around with the sciences and social studies and all sorts of different disciplines. The next reason is that statistics put you ahead in their career. When we talk to prospective employers, the number one thing they're saying today that has changed about the job market over the last 10 to 15 years is the need for statistics and statistical reasoning. So if you're thinking about going into business or psychology, I put psychology up there, but really any social science, science, programming, and any sort of postgraduate work that you would do, getting a master's degree or a PhD. The ability to interpret statistics is going to be really critical to you. In general, we say that if you know statistics, you're going to be just a little bit ahead, period. And what I mean by that is that people that know statistics, that understand the reasoning, they know when a statistic is true. They know when it's a lie, and they know when they're not given enough information. So just as a human being, it's a powerful tool. Now what I'd like to do is a quick demonstration of some of the software that we use. One of the cool things about AP Statistics is that the first semester of it is a computer module. We spent a lot of time working with this software. It's called Fathom. Now the nice thing about Fathom is that you can manipulate the data very, very quickly. What we like to do with data is we like to draw pictures. So here I got two data sets. The first one is Barry Bonds and the number of home runs he hit over a number of years in his career. And then next to him is Hank Aaron and the numbers of home runs that he hit each year of his career. And I'm going to take those two data sets and I'm going to drop them into this graph, and immediately we're going to be able to look at a dot plot. You'll notice that the Aaron data is a little more concentrated towards the middle, whereas the Bonds data is more spread out. This is the year he hit 73. Some argue that that was aided by anabolic steroids. This is the year he was injured and he only hit 5. Okay. One thing that we might think about doing with this data is turning it into a box plot, because once we have the box plot, we can look at, well, here's the middle of the data. Here's the interquartile range from this third quartile here to this first quartile here. And what we should note is that the interquartile range for Aaron here is smaller than for Bonds. And what that tells us is that Aaron is really a more consistent hitter. That if you hire him, you know about how many home runs he's going to hit, whereas Barry Bonds has a wider interquartile range and, in general, just a wider range. Let's look at the means. So I pull up a summary box here, and then we can grab the Aaron and the Bonds data, and we can drop it into the box. And you'll notice that their means are almost identical. 34.6 home runs per year for Bonds, and 34.9 home runs for Aaron. You say, well, you know what? The other thing we should look at here is the basic statistics. So let's pull that up. And now we can also see the standard deviation. You'll notice that Aaron's standard deviation is much smaller than Bonds. That goes back to what we were just saying a moment ago about the interquartile range. Aaron more consistent than Bonds. The other thing we should check out is, let's suppose we throw out this 73 home runs. We say, listen, Barry Bonds, he was using performing enhancing drugs that year. We're going to disallow that piece of data. Look what happens when we subtract it. First time, what I want you to do is I want you to look up here at the box plot. Okay? Everybody's eyes on the box plot. Here we go. Enter. And look what happened. Boom. suddenly it's clear that his median is lower than Aaron's, and that in general his box plot is shifted lower than Aaron's. Let's bring that data point back. Okay, so we're back to normal. This time what I want you to do is I want you to watch the mean. So right now they're almost identical. Bond's is ever so slightly lower. Let's subtract that 73. You got your eyes right here, and look what happens. Suddenly he's 32.8. Or in other words, he's hitting a full 2 home runs less per year than Aaron. Which leads us to the conclusion, Hank Aaron is your man. He's the guy you want batting for you. Okay? Thanks everyone for your time. I hope you've enjoyed the AP Statistics Infomercial and take AP Stat next year. If you have any questions, please don't hesitate to come see me, Mr. Klein, in room 114 downstairs in the English Hall. Take care.